Yeah, so today we're going to talk about combustion reactions. It says here on your notes, a combustion reaction occurs when oxygen reacts quickly with a substance. They are exothermic reactions, which means that energy is what? Exothermic means it's given off or released, yes? So that's what you're going to put in the blank there. All right. Energy is given off or released. Be like, you know, cooking hamburgers at home on the barbecue kind of thing. We have a combustion reaction. That fuel that you're burning could be like propane, for example, if you have the little container, or natural gas in that case. A hydrocarbon, next part here, a hydrocarbon is a substance that contains hydrogens and carbons. Hydrocarbon. Examples include, for example, how many times can I say example? Methane, CH4, and propane, C3H8. Those didn't go down there, that didn't transfer over properly. So there's a couple of examples there. Okay, are we good with that so far? Moving on here. Okay. They look something like this here, just so you know. These are some hydrocarbons, just some. These are the first four, I guess you would say. So we got methane, ethane, propane, butane, and it goes pentane, hexane, heptane, octane, nonane, decane, and you get longer and longer chains, of course. And then you can do stuff with those. You can double bond them in there. You can triple bond them. You can make them into rings, and that's grade 12 chemistry, unit 3, organic chemistry. That's what hydrocarbons are, basically organic chemistry. Okay. All right. Complete combustion occurs, and we'll talk about this, but complete combustion occurs when a hydrocarbon reacts with oxygen, so it burns, to produce carbon dioxide and water in an exothermic reaction, which means it basically gives off energy, right? Notice, and this my arrows never transfer here, by the way, but notice that water, okay, is a gas. Yes. Okay. So if you go camping on the weekend and you start to burn some firewood, right? And you're burning firewood, if it was a water, it would probably put out the fire, yes. But remember, it's incredibly hot. So we get, as a result of this, we get water gas. So you have to remember that first of all. Okay. Carbon dioxide gas and water gas. All right. Notice the state of water. All right, so I guess we're going to jump right into equations here, yes? Just so you know, complete combustion, the reactants, you don't have to copy this, but the complete combustion reactants to this type of combustion, hydrocarbon and oxygen, the product of it is carbon dioxide and water. Yeah. If you get incomplete combustion, so this could happen, for example, if your furnace isn't running right, or maybe your car is not running right, or something like that. So if it doesn't burn completely, you could get some carbon dioxide, but you will also get some carbon monoxide. And that's when it becomes dangerous, of course. So, all right, that's incomplete combustion. And then, of course, as you guys and gals know probably, carbon monoxide is not good, right? Okay, so I guess we'll start. I guess we'll do a word equation here, but again, what we're interested in is the balanced chemical equation eventually here. So, but we'll start with that, I guess. So in this case, it talks about propane. So I'd say propane. Now, the one thing to remember is in order for any combustion reaction to take place. So you know, when we fill up our cars with gasoline, right? And obviously our car, well, most of our cars, unless you have a Tesla, most of our cars burn gasoline, and you have to fill it up with gasoline, and we need air to combust that, right? And that comes in through the air filter, it cleans it, kind of thing, so it's nice and clean, and it goes into the chambers. And then if you have a gasoline engine, there's a spark plug, and it basically sparks and ignites that oxygen and gasoline, and then it basically explodes, right? Has that reaction, and that's what shoves the piston down, right? And the piston's connected to the, no, the piston is not connected to the axle. Do not get a car. No, it's connected to the camshaft. Yeah, camshaft's connected to the I'm trying to make a song here, but you guys aren't helping very much. I don't know. I can't think this morning, so whatever. But it's connected to different stuff, and then that's what yeah. Huh? Flywheel. Camshaft's connected to the flywheel, and the flywheel's connected to the transmission. Yeah, and then torque converter, and then to the transmission, and then to the drive shaft, well, which is then connected to the differential. Then it goes to your tires. True. Something like that. I was trying to make a song about, you know, your, I don't know if you picked up on that. Okay. All right. So propane, you always need oxygen in order to burn something. All right. So propane plus oxygen, we cannot forget this oxygen. Okay. We always get carbon dioxide and water. Okay. And we'll just leave it like that. Or you could say, and water vapor, I guess, if you want. Water vapor. Because that's probably more accurate. All right. So, good? Yes? We always need oxygen. And for us in Science 10, we always get carbon dioxide and water. Those are always your two products. Easy. You just have to balance it now. All right? So, I'm just going to move this up here. C3H8. Now, remember, a couple things here that we talked, one of the things we talked about yesterday. What state is propane? This is C3H8. What state am I going to put down? The answer is, yeah, so it says it's a gas, so we'll put down a gas. If I just said propane, would you, or let's say I say butane, are you going to know what state it is? C4H10. It's a molecular compound, so those are tougher, right? Usually you have to kind of be told what the states are for those, so just keep that in mind. So this is a gas. We know that oxygen is a gas, that you know. You can look that up on the periodic table because it's an element, yes. And you're going to get always carbon dioxide and water, gas, okay? Always. Okay? Guess what the products of the next one are going to be? Carbon dioxide and water, gas. Okay. The only thing that's going to change here is what we call the fuel. That fuel will change, and of course, when that changes, it affects our balancing. That's pretty much about it for now. Now, there is other products of combustion, but for our purposes, what we need to know in Science 10, this is what we know. Okay, good enough. I start left to right. Again, C3, so 3 carbons. I'm going to put 3 carbons there, yes? Is that okay so far? Okay. The only thing that you're going to run into issues here is you have to remember that these hydrogens are always even, yes? So it doesn't matter what number I put in front of there. On that side, they're always going to be even because any number I put there, 3 times 2 is 6, right? 5 times 2 is 10. Always going to be even. They may or may not be even here, okay? So you kind of got to keep that in mind. I got 8 hydrogens here. How many do I have to put over here? What number should I put here? 4 times 2 is 8. Yes, hydrogens. Again, you'll notice that we're not doing the oxygens. We're not worrying about that. That'll come at the end here, yes? So 6 oxygens here, yes? 6. And what? 4, yeah? So in this case, I get 10. Does that make sense? You got to add up both of those, obviously. You can't just look at one. Don't look at one. So then, therefore, I got to put a 5 here, don't I? 5 times 2 is 10. Okay. What happens sometimes is that these don't quite work out, and we have to go back and kind of fix them a little bit, but I'll show you the shortcut for that, or what I kind of think of, or what I do. But that's possibly what could happen. Good? Okay. What's the next one? C6H14. All right. So this is hexane. I'm just going to go ahead and jump right in. This one tells you, again, this has to tell you that it's a liquid. Otherwise, we wouldn't know. Okay. Hexane is a liquid. And we're going to add oxygen, always. And we're going to get carbon dioxide gas and water gas. All right. Now, this one here, this is what I was trying to say to you. They don't always work out nicely the first time we do this. So there's a couple options here. You're going to pick up on how, you know, especially with these ones, when you get to grade 11, it's a little different because there's lots of stuff going on. But these are basically we always have this, and then we got the oxygen, carbon dioxide, water. So they're going to be very, very similar. But something can happen with these where they don't quite balance as well. But if I start here, for example, 6 carbons, I'd probably go to here and put 6 carbons, yes? Good so far? Now, you'll pick up on a pattern here when this is going to happen, but there's 14 hydrogens here, yes? So what do I put over here? What's that? 7, right? 7 times 2 is 14, yeah? Now, again, like I said, you're going to kind of pick up on this after a while, and if you don't, that's okay. I'm going to show you what I do for these anyway. So 6 times 2 is 12, yes? So there's 12 oxygens there, right? And how many do I have here? 7. And that's a total of 19, yes? So this is where we run into this issue. Well, that's 19 there. How am I going to get 19 here? Because O comes in 2s. And that's odd, of course, and this is not odd, okay? So this is kind of what I do, but it's up to you. Some of you are like, well, we got to fix this somehow. I got to make this because, you know, this isn't going to work out. But what I kind of start out doing is I do this, and I know you're going to freak out, but I'm just like, I'm going to put 9.5 there because 9.5 times 2 is 19. You can use a calculator, okay? 19 divided by 2 is 9.5, okay? But you're like, can I do that? And of course, the answer would be no, all right? You can't have a half there. You can only do the lowest whole number ratios, yes? And this obviously is not a whole number kind of thing. Technically, we should probably use a natural number, but whatever. We need to use whole, like actual numbers here. So how do I fix that? How do I get rid of a half? How am I gonna, you know, fix this? And the answer is, well, let me ask you this. Is it technically, is it balanced right now? Do I have the same number of carbons and hydrogens and oxygens on both sides with this balancing? Sure, this is balanced, right? It's just that I can't report it like this because I need to have a whole number or a natural number there that I can put down. So how do I fix that? How do I get rid of a half? You would double it, yes? Like that gets rid of the halves, right? If you have a half of something, if I want a whole, I just double it. So what I do is I go back here and say, okay, well, this is balanced. It's all good, but this is a 1 right now. If I put a 2 here, then I would need twice as much here, yes, and twice as much here, and twice as much here to get that. And that is the lowest whole number ratio, because you might say, well, look, 2, 12, and 14, you can reduce those. I could, but I got 19 there, so I can't reduce that, right? Because I'm back to the same thing. All I did was I went through and doubled everything, and that gets rid of the half. That's the only real issue that you can run into here, okay? And again, you'll kind of notice, what does it really depend on? It depends on, this is kind of the deciding factor right there. Because remember, if there's 14 there, I have to put 7 here. Well, now that becomes odd, yes? It doesn't matter what the other one is. As soon as I put an odd number there, when I add those numbers together, I'm going to get an odd number, right? Even plus odd is going to give me odd. So it really depends on this. When you divide this by 2, do you get 7 or 9 or 5 or 3? Then you're going to run into this issue probably, okay? I just caution you a little bit on that because when they do get tougher down the road, again, you just don't want to look at that because you're going to have more of the fuel. You're going to have different types of fuel here, and so that might factor into it as well. But yeah, for us, for now, that's kind of what's happening there. Okay, questions, anyone? Okay, do we have one more? Perfect. Yeah, if you're going to times 1 by 2, like if you're going to do this times 2, you got to change everything, because if you don't, then the balancing is not balanced anymore, right? Like that's, so like when we started, I was 1, 9.5, and then what, 6 and 7. Well, that was balanced. And if I just change one of them, it's not balanced anymore. So to keep it all balanced, you got to multiply everything by 2. Yeah, yeah. So, yeah. Okay. All right, go ahead and try this one. This is C2H6, I guess, right? I'm just going to write that down because I don't like, that bothers me. All right. So just remember, all combustion reactions, the one thing that we cannot forget, we have to make sure we put plus oxygen, right? Products are always going to be the same. All right. Okay, so this here is what, I guess this would probably be ethane, C2H6. And again, we're not going to know what state that is because ethane is a molecular compound. So you're probably not going to know the states of those molecular compounds unless we tell you. So this turns out to be a gas, which it did mention that. I don't know if it does on your sheet or not, but it does here. I think this is the one we had on the sheet, right? I didn't even check. Is this the same example? Yeah, okay. Sometimes they don't match up perfectly, so. And of course, don't forget plus oxygen, carbon dioxide, gas, water, gas, okay? Water, gas. Got to make sure that that's there. So 2 carbons, again, I'd probably go to here 2 carbons, right? 6 hydrogens, 3 times 2 is 6. And again, if you haven't, you know, just kind of from the last example, you can kind of see what's going to happen here. We're going to get an odd number on that side. So we got what? You can't forget about those. That's 4 and 3. That's 7. So I need to make 7 here, which is 3.5 times 2 is 7. And then again, you want to go back. Obviously, you can't leave it like that. There's actually times where you can leave that there. That would be in Chem 30. You could do that. But you couldn't report, you couldn't, like if they said, what's the balanced chemical equation for that, you couldn't do that. But if you were trying to find something about C2H6 in this case, which would be ethane, you could actually get away with this because it would work. And because you're just getting a number from this, So there is times where, you know, that there's not, you could actually use that. However, we usually don't leave it like that for balanced chemical equations. So I'd want to go back here and double everything. So I'd say 2, double, because it was a 1, 7, 4, and 6. Okay, and make sure, you know, whatever you decide to do, I just wanted to do it quicker here because I want to get done here. But if you're going to do that, you know, make sure it's neat so we know which number is going with what. Preferably erase it or write it over again with the correct numbers there, so it's nice and neat. Okay, good. Any questions, anyone? Okay, so our homework today here is obviously on the back. Okay, you're going to start out with some, well, the first, number 1 there looks like a lot of this kind of thing. All right, so you can get some practice there. Then once you get to 2, okay, we're going to start reviewing a little bit from yesterday as well. So you're going to get some formation, decomposition again, and combustion mixed together now, okay? Same with 3. You'll notice that we've mixed them all together. So you can kind of start looking at those. 4, 5, 6, and 7 as well, okay? And we got over a half an hour left. So we're going to make you do the rest of that other page too,